Hi everybody, welcome back. In this video we're going to be looking at a multi-part question here from the labor demand side to ultimately look at how much labor a firm should hire, how many workers, and what will their profit be given all of this setup. So we have a wage, a rental rate of capital, output price, and then the production function here, which will determine quantity produced. We could also write that as the square root of employment over the square root of capital. We could use calculus, calculate the first derivatives with respect to each input in order to get the marginal products. But here we're given our marginal product of labor, we're given our fixed capital stock, and so yeah, we're gonna figure out what amount of labor we should be hiring. So that's going to be the E, and profit, which we denote with pi. And so let's write down these formulas that we're going to have to calculate. The profit ultimately will come from total revenue, price times output quantity, which we'll calculate with the production function up there. So total revenue minus total costs. The costs come from two spots: the labor costs, wage times the number of workers, and the capital costs, the rental rate of capital times the amount of capital. So we have the price. We'll calculate the quantity. We have the wage, $10 an hour. We'll calculate employment, and then we have the rental rate of capital and the capital stock. In order to calculate the number of workers here, E, we'll have to recall from labor theory that the optimal bundle of capital and labor, optimal bundle of capital, the optimal bundle of optimal labor will come from the value of marginal product from labor equal to the wage. Okay, so the value of what a person can produce, the next worker can produce, has to be at least equal or greater than their wage in order to make that hire a profitable one. So as long as it's higher, you'll keep hiring people as long as it's higher than the wage. And then once they're equal to each other, that's where we stop. So we're going to ultimately need to use this formula, but we don't have yet the value of marginal product, so we need to calculate that as well. So let's also recall that the firm's labor demand is that value of the marginal product of labor. Okay, so that'll get us our, if we get our value of marginal product of labor, then we can plug it into this formula here. Now, value of marginal product of labor, last bit that we have to recall from the theory. So all of the lead up to this is kind of taking the theory as given, so you can go back and kind of look over that. But if you recall, that's just going to be the marginal product of labor, so how much output can a worker produce, times the price of that output, and so it'll be the value of what that worker is able to produce. So this we have the marginal product of labor, we have the output price, and so now we can finally calculate all of these things. So marginal product of labor, that's 1/2 K over E to the 1/2, which is the square root of K over E, and we can plug in what we know here. So, times the price. Okay, let's plug in, let's go a little bit to the right just to save some room, and plug in what we know. So we have capital stock, K, is 1,600 units. And over E, that's what we're going to be solving for, times P, the output price, that's $50. Okay, so then, continuing on, this square root of 1,600 over square root of E, we can break that into 2 bits. Square root of 1,600 over square root of E times 50. Right, square root of 1,600 is 400. So let's start going down this direction. 400 over square root of E times 50. All right, and then if we do a bit of consolidation there, I will skip a couple steps, but you can verify that this will come out to 1,000 over square root of E. So value of marginal product of labor, 1,000 over the square root of number of workers. We're going to take that and plug that into this formula here. So value of marginal product equal to the wage to find the optimal amount of labor. So let's do that. Value of marginal product of labor equal to the wage. That's 1,000 over the square root of E equal to the wage given to us at the top of the problem, $10. So that's equal to 10. And then we solve, and we can solve for E. All right, let's take the E over to the other side and divide this by 10. So we have 100 equals square root of E. Square both sides, and we'll get E is equal to 10,000 workers. Okay, so that's our optimal amount of employment. So we're almost there. We have employment. We'll be able to plug that in here. We have rental rate of capital, wage, employment, and last thing we'll have to do to solve this profit function is look at Q, output, which we can now solve because we have E. All right, so Q, output, is equal to the square root of employment times the square root of the capital stock. That's square root of 10,000 times the square root of 1,600, or 100 times 400. Is that, yeah. No, 100 times 40. Let me just double check that. Yeah, 40. Okay. And then that gives us a total of 4,000. Okay, so output with the optimal number of workers is 4,000. And finally, we can calculate profits. Total revenue minus labor cost minus capital cost. And we have all of those. We can simply plug in our numbers. So the output price was $50 times 4,000 units. The wage is $10 times 10,000 workers. rental rate of capital is $25 times 1,600 units of capital. We plug that in and solve, and we'll end up finally with a profit of $60,000. Okay, so a lot of pieces there, but yeah, just take sort of what we know, what we need to solve for, and then what we know from theories and the optimal conditions, and then just kind of churn through and plug in and solve. So yeah, that'll do it for this problem, and we'll see you in the next video. Thanks.